Okay, now example 4, we are still using our quotient property. Okay, but this time it says express as a single logarithm, so we have to bring this to one logarithm and simplify. So like in example 2, we will be solving for the value of the log. Okay, so not only going to bring it to one logarithm, we will be solving for it. So this time we are reversing our quotient property. So I'm giving you a subtraction problem and we're going to combine it into one logarithm, which again, you put the first log is your numerator and the second number in the log is the denominator. So we're going to use that same principle when we start this problem. Okay, so we're going to have a single log, so I'm going to start with one logarithm. That's it. And we have the same basis, so we're good to go there. I'm going to write my base, which is a 9. Okay, and then we just write the first number in the first logarithm is the numerator, so I'm going to throw it up top. And the second number that is inside of my second log is the denominator. And I know I'm dividing, you guys, because there's this subtraction symbol. That tells me we will be dividing. Okay, now, before we solve this log, I'm going to simplify this log first. Okay, so this is going to be log base 9. I'm going to simplify my fraction if I can, because if our numbers are smaller, it is much easier to work with. So, 3 divided by 27. We need to think about something that goes into both 3 and 27, which you already thought of it. It was a 3. So I'm going to reduce my fraction down and divide each of those by 3. So 3 divided by 3 will give me a 1. Okay, so I divided that one by 3. And then 27 divided by 3 will give me a 9. Okay, so I just kind of made the problem a little smaller, which will be easier when we solve. Okay, so when we solve, remember we start by just setting it equal to whatever you want. I'll just set it equal to x to make my life easy. Alright, and then the next step is to convert this bad boy into an exponential. Okay, so this is just like what we were doing in our previous problem. So if you think you know how to take it from here to solve for x, I highly encourage you. But if not, you can keep watching. Okay, so the base of my exponential is the base of the log, which is my 9. Okay, and then remember, these two are going to trade places. So my x is going to hop on one side with my 9. Alright, and then the 1/9 will be on the other side. Which I'll just write it in one color to make my life easier. Okay, so let's solve for x, you guys. So, the goal is to get the same base, but remember, we can't work with this fraction. Fractions you cannot work with when you have an exponential. So I'm going to make it so it's not a fraction anymore. Okay, this is secretly 9 to the first power. And remember, the way that we move something to the numerator, the exponent will switch signs. So instead of being 9 to the positive 1, it will now be 9 to the negative 1. Okay, so we have 9 to the x power equals 9 to the negative 1. Okay, and guess what, you guys? We have the same base on both sides already. Isn't that exciting? Okay, so since I have a 9 as my base on both sides, we can instantly drop our exponents down. Holy hot dog. Okay, so I'm going to drop my exponents down. Alright, so my final answer will be x equals negative 1. And that's it, you guys. All that up here secretly just equals negative 1. Fun times. Alright, as part B is pretty much the same. So again, if you want to try part B without my assistance, I highly encourage it. Fast forward to the end of the video and see if you got the right answer. Okay, so we have to express this bad boy as a single logarithm. So that means I'm only going to have one. Just one. And both of them have the same base, so I'm good to go there. So my base is 2. And since I'm subtracting, I know I'm going to be dividing. I'm going to put the numerator up top, which the numerator is the number of my first log, so my 8 goes up top. And then I'm going to divide it by the denominator, which is the number inside of my second logarithm, which is a 4. Okay, so before we solve this bad boy, I need to reduce this down to make my life easier. So this will be log base 2. Alright, and I need to think of something that goes into both 8 and 4. So let's think here. You got it. You guys are so good. Okay, you were correct. The answer is 2. Okay, so I'm sorry, 2. Hello, Miss Long. 2 does go into both, but I know that you guys saw an even higher number that goes into 8 and 4. Look, you already knew before I knew. It is 4. 4 goes into 8 and 4. So I'm going to divide each of these by 4. 8 divided by 4 is 2. And 4 divided by 4 is 1. So this is 2 over 1, which, you guys, is just 2. Okay, so technically that's just 2. Alright, and let's start solving. So, to solve for whatever that log equals, I need to set this bad boy to x, equal to x, sorry. Alright, and then we need to convert it into an exponential. So the base of my exponential is the base of my log, which is base 2. Okay, and then remember these two bad boys are going to trade places. So my x is going to hop over with my 2. And the 2 over 1, I'm just going to write as 2, you guys, since 2 divided by 1 is just 2. Okay, which since I don't see an exponent on this 2, it secretly is a 1. And holy hot dog, you guys, we already have the same base on both sides. We already have a 2 on both sides. So I can instantly drop down my exponents and get my final answer. So x equals 1. So all this up here just equal 1. Isn't that cool? Okay, and probably some of you guys already caught it. If we look at this step, you probably already knew the answer. Okay, from here we saw that log base 2 of 2 equals 1. Okay, and if you remember from the last section, this is using the identity rule, which remember, if you have, equals x. Sorry, not 1. Okay, sorry, I was thinking ahead. But anyways, if we bring this down using the identity rule, remember, if you have the same base of the log as the number in your parenthesis, remember, it's just 1. Okay, and that's because 2 to any, or if you have the same base raised to a power to get itself, the only power that it works for is 1. If we rewrote this, 2 to what power gives me 2? Well, 2 to the first power. Okay, so whenever you see this repetition right here, the base is the same as the number in the log, it just equals 1. So technically, from this step, you could have stopped if you wanted. So either way. Alright guys, awesome job.